Hi, in the last video, I gave you very brief introduction of the matrix, which is the arranging a number in the rectangular form, right? For example, this is a 2 by 2 matrix, okay? So basically in this chapter, we'll be talking about 2 by 2 matrix and its inverse, its multiplication with another matrix and so on, okay? And also we discuss about the determinant of a matrix. So here may be numbers there, right? So these are A, B, C, D will be numbers. So how do I find out the determinant of a matrix? To find out the determinant, how do we multiply? This multiplication is positive and this multiplication is negative, right? And then you add them. So it will be AD minus BC. That's the determinant of the matrix. All right. And then what we also did on that video is, so this is a system of linear equation, meaning a pair of linear equations, okay? So this pair of linear equation can be written in the product of matrix form, meaning you can write the first matrix, you can write just the coefficient A11, A12, A21 and A22, right? And then this second matrix you can write x1, x2. And you may be wondering why there are x1, x1 and x2, x2. Why I am writing just x1 and x2 only? Why I don't write x1, x2, x1, x2 or x1, x1, x2, x2? So this is how the product of the matrix is. I will give you another example here, but how it works is, how do you multiply two matrix is, you multiply this first with this one, okay? And then plus you multiply this with that one, okay? So it is like L. You do just this and then that way, okay? So A11 times x1 plus A12 times x2, it goes to the first line and equals to B1. And then similarly A21 times x1 and plus A22 times x2. A21 times x1 plus A22 times x2 will be equals to B2. So this is how you multiply. Now you see that what is the size, what is the dimension of this matrix? It is 2 by 2, right? Because there are 2 rows and 2 columns. So we write this as 2 by 2. What is the dimension of this matrix? It is 2 rows and only 1 column, 2 by 1. See, 2 matrix can be multiplied if the number of column of the first matrix is equals to the number of row of the second matrix. You see that? If they are equal, then you can multiply. Now, what is the dimension of the product? Will be the remaining numbers, 2 by 1. So that is 2 by 1. Okay. Now see, this matrix can be written as A times X equals to B. This is like A times X equals to B, right? Where A is A11, A12, A21, A22, and then X is X1, X2, and then B is B1, B2. Okay, so you can write this system actually as A times X equals to B. Now what we said is, we define as if the determinant of a matrix A, that matrix, coefficient matrix A is not equals to 0, we call non-singular. If that determinant is 0, we call singular. So in the case of non-singular matrix A, then the inverse of that matrix A is denoted by 1 over determinant of A, right? 1 over determinant of A, and then times the cofactor matrix. But what is the cofactor for the 2 by 2 matrix? Is just straightforward. What we do is you swap this. You basically swap this with that one, right? You swap that, and then you multiply this by negative side. You see that? The other diagonal by the negative side. That's what we do. So this is the inverse of that matrix. Now, why do we need the inverse? Is if you want to solve this equation, this system of equation by the matrix method, then X, meaning x1, x2 will be A inverse of that matrix A times the B, means the right hand side matrix. That's what you will be. This is how we solve by the inverse matrix method, okay? And then we also did one example, but let me give you, if you have not done the linear algebra before, or the matrix, if you have not done the matrix before, so let me show you how do we multiply two matrix, okay? As I mentioned, so what is the let me write on 1 2 3 4. So this is 2 by 2 matrix. Why? Because it has 2 rows and 2 columns, right? So 2 by 2 matrix. Okay, now let's say that this is like -1, -2. So this is 2 by 1 matrix, 2 by 1. See, these two numbers match each other, right? This number, the number of column of the first matrix and number of row of the second matrix, they match, so we can multiply. They match means we can multiply. If they don't match, we cannot multiply. Now what is the after you match them, so you will get a matrix of 2 by 1. You will get a matrix of size 2 by 1. That is the remaining numbers here, right? How do I do that? How do I do the matrix multiplication then? So the idea here is you multiply this with the first one, this with the first one, and this with the second one, right? So 1 times 2. 1 times 2 is 2. 1 times negative 1. 1 times negative 1 is negative 1, and then plus 2 times negative 2 is negative 4. Similarly, do the same thing with that second row. So 3 times negative 1 is negative 3, and then 4 times negative 2 is negative 8, plus negative 8. Okay, so how much do you get? Basically, the first one is negative 4 minus 1 is negative 5, negative 8 minus 3 is negative 11. That is the product of these two matrices. Similarly, if you have, let's say, if you have 1, 2, 3, and then let's say there are 3 rows, right? And then okay, and then let's say 4, 5, 6, and suppose you have, let's say you have let's say 1, 0, minus 1. Okay, suppose you are multiplying, this is 2 by 3, 2 by 3 matrix. This is 3 by 1, right? Why? Because there are 2 rows. First of all, you write row, and then 3 columns, 2 by 3, and then there is first, second, third, 3 rows and only 1 column. How do I multiply this? Can we multiply first? The answer is yes, because these two numbers match, right? And then what is the resulting number? It should be 2 by 1. It must be 2 by 1. Okay, so how do I do that? Is you again do the same thing. Multiply this with the first, this with the second, this with the third. What do you get? 1 times 1 is 1, plus 2 times 0 is 0. 1 plus 0 minus 3, because 3 times negative 1, right? Similarly, this one will be 4 times 1 is 4. 4 plus 0, because 5 times 0 is 0. And then plus 6 times negative 1 is minus 6, right? So what do you get? Basically, you get 1 times negative 3 is negative 2, right? And then 4 times negative 6 is negative 2 as well. This is what you get. Okay, so 2 by 1 matrix. Although you are multiplying 2 by 3 times 3 by 1, you got 2 by 1 matrix. That is, there are 2 rows. Because see, although you may ask, there is you are writing 2 times 1, but why there is like 1 plus 0? So this is a single number, right? So that's why you got negative 3. This is also another single number, because there is 4 plus 0 minus 6. So negative 2 minus 2. So this is 2 by 1 matrix. So this is the product. Now, you can think of matrix is a transformation. Why matrix is a transformation? Because we were taking like 1, 2, 3, 4. It is a matrix, and it was multiplying with negative 1, negative 2, and it was giving you negative 5, negative 11. Look at this. This matrix is taking this vector, I would say, this vector or this matrix into another matrix of that size. You see that here? Of that size. Okay. So here, so this matrix is taking this vector or this matrix to another matrix of the size of 2 times 1. So you may get different size matrix. Okay, not a problem. But it is basically, this matrix is taking A times X equals to B, meaning A is taking X into B, because A times X is equals to B, meaning if you multiply X with A by A, then you will get a B. So you can think like A is a transformation. Okay, that transfer, that maps, I would say, X with B. You can think of that way. Okay, so you can think of that way. So so now what I want to do is I want to write down a definition of eigenvalue and eigenvectors. Okay, so sometimes let's say matrix A can take a vector X to 0. When does matrix A can takes a non-zero vector to 0 is if A itself is 0. If A is a 0 matrix, then if you multiply 0 matrix with any, let's say 0, 0, 0, 0. Let's say X is, let's say 5, 6. What will that be? That will be 0, 0, right? This is what you get. Meaning this 0 matrix is taking any other non-zero matrix to 0. It will absolutely take 0 matrix to 0, but this matrix is taking any other non-zero matrix to 0. So this matrix is taking anything to 0. So it is kind of transformation, right? So sometimes a matrix can map, let's say A matrix. If you write A times X, you may get some multiple of X. Lambda is a constant, okay? Sometimes a matrix A can map a vector X, or a matrix, or a column matrix X, or a vector X, I can say, is to its multiple of that. Lambda is a number, multiple of that matrix X, okay? In that case, so let me write, instead of X, I would write V instead of X, okay? Because since this is just only one column, let me write down V as a vector, okay? So sometimes a matrix A can take a vector V to its multiple, okay? To its multiple. So lambda is a number. So in this case, we call lambda is eigenvalue and V is a eigenvector, okay? So in this case, we call V is eigenvector of matrix A, eigenvector, and then lambda is called eigenvalue of matrix A, okay? So I am giving you the definition of eigenvalue and eigenvector first. So before I go to the eigenvalue and eigenvector, I want to define a matrix called identity matrix, okay? Identity matrix is like 1 in the numbers, okay? So whenever you multiply a matrix by identity matrix, then you will get the matrix itself, okay? For example, let us do that. 1 0 0 1 multiply with 3 4. What do you get? If you multiply these two matrices, what do you get? 1 times 3 is 3, right? Plus 0 times 4 is 0, right? And then similarly 0 times 3 is 0, plus 1 times 4 is 4. What do you get? You get 3 4. See, this matrix takes a vector by itself, to itself. This matrix transfers this vector to itself, or maps this vector to itself. This is called identity matrix. So we denote this by I. And what is how many rows are here? 2. How many columns are here? 2. We write just 2. I2 is identity matrix. Identity matrix of order 2. We call like that, okay? This is identity matrix of order 2. If you want to know the identity matrix of order 3, it will be 1 0 0 0 1 0 and 0 0 1. So basically in the identity matrix, the diagonal elements are all 1 and non-diagonal elements are 0. So these are 0. So all the diagonal elements are 1. This is called identity matrix, okay? I2 is the identity matrix. Now I have to define eigenvalue and eigenvector. Eigenvalue and eigenvector. Okay, let A is a square matrix, okay? A vector V is called eigenvector of matrix A if A takes the matrix V to lambda times V. If AV equals to lambda V, okay? All right, so what can we say from here? The number lambda is called eigenvalue So this vector v is called eigenvector, this vector v, okay, and that number lambda is called eigenvalue, okay. So we call, to find out the eigenvalue, first of all we'll find out eigenvalue, okay. So if you are asked to find out eigenvector and eigenvalue, first of all we try to find out the eigenvalue lambda, okay. So to find out the eigenvalue lambda, what we do is we try to find out the solution of a characteristic equation. But what is characteristic equation first? Let's talk about that. Note, we can write AV equals to lambda v as AV minus lambda v equals to 0. Okay. Now let us take v out. You can write A minus lambda I times v equals to 0. So what is I? I is the identity matrix 1 0 0 1. It is I2. Okay, 1 0 0 1. And why can I write lambda v as lambda times I and then v? Because if you distribute this, you will get A times v minus lambda times I times v. Because I times v is v itself, right? Because you see that? This is like I times v equals to v. We got that here, right? So if you multiply I, the identity matrix, to any vector, you will get the same vector. That's why you can write down that I is like 1 in a number, okay? So A minus lambda I times v equals to 0. The equation given by A minus lambda I, the determinant of this matrix, whatever you get here, equals to 0 is called characteristic equation. Okay, this is called the characteristic equation. But how do I find out characteristic equation? I'll give you example. How do I do that? Okay, so what is A minus lambda I? We will talk about that. How do we add two matrices? How do we subtract two matrices? We will talk about that. Okay, so but first of all, let us see. Let us take a very simple example. Then you will see, or you can basically do this. We can find out the characteristic equation of this one. Okay, let us suppose that A is what is our A? A is A11, A12, A21, A22, right? So what we do is, that is, let me write down, that is determinant of what? What is A? A is A11, A12, A21, A22 minus lambda times what is I? I is 1 0 0 1. Determinant equals to 0. Now look at this. You can distribute this lambda to here, right? What do you write? You write A11, A12, A21, A22. This is a matrix, right? And minus, you can distribute this lambda. Do you know how to distribute a number inside a matrix? You need to multiply each of the component, each of the element, or we say each of the entry by that number. It will be like this. Lambda times 1 is lambda, lambda times 0 is 0, lambda times 0 is 0, lambda times 1 is lambda, equals to 0. You see that? Now how do I subtract two matrices? So we can subtract the matrix if they have the same size, meaning this is 2 by 2, this is 2 by 2. So we can subtract. Now how do I subtract? You subtract the first minus the first one, second minus the second one, third minus third one, fourth minus the fourth one. So what do you get? You get the determinant. So determinant of a matrix basically is, you can write just the determinant here. Okay, so the determinant of a matrix is just the determinant here. So I don't want to write that because there were two matrices. That's why I was writing determinant outside and matrix inside. Now when I combine these two matrices into a single matrix, so since I'm finding the determinant, I don't need the bracket there. So I want to just write the determinant only, just the vertical lines. A11 minus lambda, A11 minus lambda, and then A12 minus 0 is just A12, right? A21, and then A22 minus lambda, right? A22 minus lambda. This is the determinant of that matrix. Now I want to simplify that determinant. How do I do that? Let us look at that. So Let me continue from that. Let me copy that for once, and then we have the determinant of a11 minus lambda, and then a12 and a21 and then a22 minus lambda equals to 0. Now how do you multiply that? You multiply this positively, this you multiply this negatively, right? So you write a11 minus lambda times a22 minus lambda. This is how we find out the determinant, right? Minus a12 times a21 equals to 0. That's what you get. Okay, guys? Now you need to FOIL this. What do you get? You get a11 times a22 and then minus lambda times a11 minus lambda times a22 plus lambda square minus a12 times a21 equals to 0. That's what you get. Okay. Now if you write this in the quadratic form of lambda, you will get lambda square. Okay. And then what? And then you get minus lambda times lambda square minus lambda times, what do you get? You get a11 plus a22, right? And then plus, you can write a11 a22, right? And then minus a12 a21 times a21, right? Because these are times equals to 0. So this is the characteristic equation. Okay. So another word that people use is trace. Okay, what do you mean by trace? Trace is, what is the matrix A? This is the matrix A, right? So matrix A is what? A11, A12, A21, A22. Okay, so people use that the sum of these two elements is called trace. Sum of these two elements is called trace. Okay, people call that as a trace. So you can write this as a lambda square minus trace of A plus determinant of A, or you can write that A and then just like absolute, just two vertical lines and then A inside, okay, equals to 0. So this is the determinant of A, right? Why? Because A11 times A22 minus A21 times A12. That is the determinant. This is called the trace. The sum of the diagonal element is called the trace. So this is the characteristic equation. Okay, this is called the characteristic equation. All right. So what I'm going to do next is I'm going to ask you how to find the eigenvalues and eigenvector of a matrix. I'm going to give you one example on finding the eigenvalue and eigenvector of a matrix. Okay, guys. So let us do that. Let us do the example. So how do I find out the eigenvalue of this? And how do I find out the eigenvector of this? Okay. So first of all, we need to find out the characteristic equation. Okay. Solution. Let lambda be the eigenvalue and V be the eigenvector of A. Then by definition A V equals to lambda V, because A is taking V to its multiple, right? So how do I write down that? That is A minus lambda I times V equals to 0, right? A minus lambda I equals to lambda I times V, because you can bring that lambda V to the left and then take V out. So what is left is lambda times I is left, because I times V is always V. That is the reason. So how do I, what is the characteristic equation then? Characteristic are characteristic equation is the A minus lambda I equals to 0. So what is that? That will be A is 2, 7, -1, -6 minus lambda times, what is I? I is the identity matrix that has 1, 0, 0, 1. that is I2 always, okay, equals to 0. So if you simplify, what do you get? You get 2. So see, when you distribute this, you will get, let me do that part too. 2, 7, negative 1, negative 6 minus negative lambda 0, 0, negative lambda, positive lambda, right? Because minus is there. So I'm just distributing lambda only, just keeping minus sign there. Lambda equals to 0. What do you get there then? Then you get determinant. Now you subtract 2 minus lambda, 2 minus lambda, and then 7 minus 0 is 7, and then negative 1, and then negative 6 minus lambda equals to 0. Now you write down the determinant of this, right? So you multiply this way, and this one is negative multiplication. So what do you get? You get 2 minus lambda times negative 6 minus lambda, and then plus 7 equals to 0. So what do you get? If you simplify, you will get negative 12, right? And minus 2 lambda, and then plus 6 lambda, and then plus lambda squared plus 7 equals to 0. So what do you get? You will get lambda squared plus 4 lambda minus 5 equals to 0. If you solve this, what do you get? You get, how do I solve this one? So you get lambda plus 5 and then lambda minus 1 equals to 0, right? So if you solve this, lambda equals to negative 5 and positive 1. That's what you get, the lambda. So these are the eigenvalues. So eigenvalues. How do I find out the eigenvector? Eigenvector will be the one that takes A to the same vector, right? So how do I do that? Is now to find out the eigenvector, let me write down for eigenvector. So we need to take each of the eigenvalue. Okay, for this eigenvalue you will get one eigenvector. For this eigenvalue you will get another eigenvector. Okay, so for eigenvector, first take what we take first. Lambda equals to 1. Let's take lambda equals to 1 first. What do you get? You get AV equals to lambda V implies. So what is A? A is 2, 7, negative 1, negative 6. Let us say V is a matrix, let's say X or vector X comma Y. Okay, equals to lambda is 1 and then X comma Y. Okay, so now you simplify that left side and the right side. What do you get? 2x plus 7y, and on the bottom one it is negative x minus 6y. You see that on the left, and on the right you will get 1 times x is x, 1 times y is y. Now see, these two matrices are equal, so the first one must be equal to first one, second one must be equal to the second one. What do you get? 2x plus 7y equals to x, and then negative x minus 6y equals to y. You see that? So that is, what do you get? You subtract x. What do you get? You get, and then take the y on the other side. What do you get? So x equals to, if you subtract x, right, minus x, okay, and then you do plus 6y. What do you get? You get x equals to 7y. You see that? And what is the another one? You get negative x equals to, by the way, x equals negative 7y, right? And then you see that x equals negative 7y, because you'll have to subtract you'll have to subtract 7y on both sides. You'll get x equals negative 7y. From the second equation also you will get x equals to negative 7y. So you get the same equation from both, right? Now what do you do there then? Is you get x equals to negative 7y. So if you said y equals to 1, you can pick y equals to 1, x equals to any number. It is okay, but usually for simplicity you take y equals to 1. Take y equals to 1. What do you get for x? X is negative 7, right? This implies x equals to negative 7. If you take y equals to 1, you will get x equals to negative 7. So what is the vector v then? Vector v, you can write the arrow on the top. Vector v equals to x is -7, y is 1. You can write like this. Okay. Now, this is for lambda equals to 1. Similarly, for lambda equals to -5, you'll have to do the same thing. Okay. Let me show you that one too. So for lambda equals to -5, again, for lambda equals to -5, you do AV equals to lambda v. A is again 2, and then 7, -1, -6. V is, let's say, xy, okay, equals to -5, and then xy again. Now we need to find out xy, right? So it is 2x plus 7y and -x minus 6y equals to, you get -5x, -5y. That's what you get. Okay. Now you set them equals. 2x plus 7y equals to -5x, and then -x minus 6y equals to -5y. So this implies if you add 5x and then subtract 7y, what do you get? You get 7x equals to -7y. Here also you will get, let's see what you get. -x, this implies -x equals to, if you add 6y on both sides, you will get equals to y. See, x equals to -y. So either way, you will get x equals to -y. This implies x equals to -y. This implies x equals to -y. So from both, you will get the same thing, right? So x equals to -y. So if you said y equals to 1, then what do you get? Implies x equals to -1. So the eigenvector v equals to x is -1, y is 1. Or you can write x is 1, y is -1. It's the same thing. Okay. So this is the eigenvector you get. All right. So what are the eigenvalues and eigenvectors then? What is the final answer then? Your final answer look like, for lambda equals to 1, v is -7, 1. Okay, you can write parenthesis or bracket, it doesn't matter. Okay, for matrix. For lambda equals to -5, you get v equals to -1, 1. That is the final answer. Okay, so this is how you find out the eigenvalue and eigenvector of a matrix.